Okay, so we're going to continue with probability. Our previous section was basic and classical probability, and we had two-way tables and different things and expected values. Well, here we're going to work with the probability distributions. And one of the probability distributions is the geometric, and if we have time, we'll also do a little bit on the binomial today. So first off, we want to talk about a specific type of probability distribution called Bernoulli Trial. And this is an experiment that has two possible outcomes, success and failure, all right? And in the case, the probability of success is the same every time the experiment is conducted. If I flip a coin, I know the probability of success is 0.5 every time I flip it. And basically either I get a heads or I get a tails, so it's a success-failure situation. Now, I will say that this can be somewhat confusing because rolling a dice can also be a success-failure situation. And you should be going, well, Mr. Spencer, it has more than two possible outcomes because I could get a 1, 2, 3, 4, 5, or 6. And you are correct. It does have more than one possible outcomes. But if I only win if I get a 4, then 4 is my probability of success, and 1, 2, 3, 5, and 6 would be failure. So basically, can I divide it up into a yes-no situation? Or maybe odd numbers are a success and even numbers are a failure, or things like that. Once again, the word discrete basically means we're working with whole numbers. We're not working with any fractional values. Continue says that we can take on any fractional value. The geometric distribution, which we're going to talk about, is a discrete probability distribution, and it represents the number of failures before you actually get a success. Now, please remember, we have to have two possible outcomes or be able to define it as two possible. A success and failure. The probability of success is constant as the probability of failure. By the way, so we're going to have success be represented by a P, failure is going to be represented by a Q. And you're like, well, gosh, that doesn't help. Well, there is a relationship. Q equals 1 minus P. So Q equals 1 minus P, so there's a relationship. Trials must be independent. In other words, what happened before can't happen, what's going to happen. So when I flip a coin, the fact that I got heads will not affect the next flip. With a geometric, now this part's not binomial, this is for geometric only. We're going to continue until we get our first success. So theoretically, if I flip a coin, and if I say heads is the success, the first flip might not be a head, the second hit flip may not be a heads, and actually I could flip the coin forever and not get heads, theoretically. Real life, I'm going to be a little freaked out if it doesn't happen after about the fourth time. Next thing, number of trials, the successes and failures are discrete. So the number of times I do it is going to be a whole number. So when I flip a coin, I can only flip it 5 times. I can't flip it 5.5 times. All right. We have a formula. So this is the formula for geometric, which is basically the number of failures raised to the number of times I do it minus 1 times the probability of success. So the number of failures times a raised to the power of the number of times I do it minus 1 is times the success. Now, we've actually, believe it or not, have already been doing something like this. We would sit there and we make blanks. If I wanted my first success to occur on the fourth one, this would be a success, and these would be fail, fail, fail. All right, so basically, this right here is just the formula for the blanks. Mr. Spencer, are we going to have to memorize the formula? No, I'm not actually going to make you memorize the formula. Matter of fact, I almost always use this work as my work shown when I do it on a calculator. And by the way, the calculator is about to be a really good friend for you. If I ask you the mean or the average or the expected value for geometric, if I ask you for the expected value, you're just going to say it's 1 over p. And you're like, I don't understand. So that's 1 over the probability of success. 1 over the probability of success. And I'm going to show you in a moment that it makes sense. This is the formula for variance, which is failure over success squared. Standard deviation is the square root of failure over the probability of success. So, geometrics, we have 2 different ways to phrase them. Please pay careful attention to this, star them. What is the probability that the first success, that phrase first success, is going to let me know that I'm looking for a geometric. And it says will occur on a specific trial or a given trial. What's the probability that my first heads occurs on the 4th time I flip it or the 4th time I try it? That's going to be what's known as a PDF, because we have a specific trial that it has to be successful. Had to be successful on the, in this case, the 4th one. The next one, what is the probability the first success will occur no later? Well, that means that it can then by the 4th one. That means it could occur on the 1st one or the 2nd one or the 3rd one or the 4th one. It didn't say which one it had to be on. It just had to happen within the first 4, the first 5. So at any time by a specific time is going to be known as the geometric CDF. And this is this right here, the PDF, a geometric PDF is for a specific value. This is for cumulative. Cumulative being like it could be the 1st, 2nd, 3rd, or 4th. Now, I'm told you I was going to relate this to something you already know. If I ask you how many times do you expect to flip a coin before you say get heads, most people go, well, the probability is 1/2, so I'm going to say 2. And you're right. That's exactly what's happening, because the probability of a tails is 1/2, but we expect to get heads if we flip it twice, because we basically went 1 over 0.5 or 1 over 1/2, and that equals 2, so we expect to flip it twice, and that's how you do the expected value for that problem. How many times would you expect to roll a die in order to get a 3? Well, most of us would go, we can get a 1, 2, 3, 4, 5, or 6. The probability of getting a 3 equals 1/6. So I expect to go 1 over that 1/6. I'm like, oh, if I roll it 6 times, one of those should be a 3. Does that mean it's going to happen on the 6th one? No. It could happen on the 1st one. It may happen sometime after the 6th time. But on average, if we did it over and over again, we would expect it to be the 6th one. So on average, we would expect to have to roll it 6 times. All right, so here are the calculator commands. I'm not even going to go over those because you can read them yourself, and until we do a specific problem, it's not going to help you out a whole lot. So let's actually do a little problem here. And suppose, let me make a little adjustment here to my screen. Suppose only 17% of guys at some high school, Reagan, are honest. What is the probability that the first honest guy that a new girl at school meets will be the 5th guy to whom she's introduced? Well, this is a geometric PDF because it's not any guy, it has to be the 5th guy. So if I was showing my work, I would do this. I'd go 1, 2, 3, 4, 5. This guy's honest. Liar, 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 liar. So this is going to be 0.17. The complement of 0.17 is 0.83. And so basically, this is going to give me 0.83 to the fourth power times 0.17. Notice this is a success. This is the honest guy. These guys are considered failures. And our formula was Q to the K minus 1 times P. And once again, you don't have to write that down. But I'm just going back as to what it was. Q stood for failure. And remember, Q equals 1 minus P. So this is failure. This is success. K was the number of trials. 1, 2, 3, 4, 5. 5 minus 1 is 4. So that's how that worked out, okay? So let's put that in the calculator and show you how that works. I'm going to go pretty slowly on this. And I realize you can't see the entire screen. So I'm going to go stat. Excuse me, that's a lie. I'm not going to go stat. Please pay attention. Second, followed by vars. This button right here. Really, because the reason we're doing that, it says DISTR. I know you probably can't see that due to my shadow. That's distribution. So second vars. I should get a screen that looks like that. And I don't see geometric, but if I scroll way, way down, I have E and F. E is a PDF, F is a CDF. Because we want it to happen on a specific person, the fifth one, we're going to use a PDF, so geometric PDF. My probability, that's what that P stands for, of the guy being honest is 0.17. So in this case, P is 0.17. My X value is the number of guys. So in this case, 5. So P, you need to write this down every single time. P is 0.17. X is 5. So I plug in 5. Put enter a couple times, and there I get this value, 0.0807 equals 0.0807. And that's my answer. And we're done with that problem. Now, I know I took a long time to do that, but when we actually go through it in just a moment and start actually doing scenario work with it, it'll move fairly fast. Now for the one that takes a whole lot of time. We're going to do a PDF. We're going to show you this work by a PDF, even though this is really a CDF. It says, what is the probability that the first honest guy she encounters will be no later than the fourth? So we have no later, which means we could be on the first one, the second one, the third one, or the fourth one. So that means I need to do, what's the probability of it happening on the first one, plus the probability of the second, plus the probability of the third, plus the probability of the fourth. And I'm going to go about this the long way, and then we're going to show you a shortcut in just a moment. So it could be the first one. So the first one, the probability that it occurs on the first one is just a single blank. In this case, it's 0.17. Well, that was easy because that's the probability of success. Number 2, basically, it's going to be on the second one. So we're going to have a fail and then a success. So this is a honest guy. So this is going to be a liar followed by an honest guy. Honest guy is always 0.17. So this is going to be 0.83 because it's 1 minus the 0.17. Then we're going to have the third one. So we're going to have 1, 2, 3. And this is going to be a liar, liar, then honest. So this is 0.17. So this right here is 0.83. 0.83. And number 4, we're going to have 3 liars and then 1 honest guy. Once again, the honest guy is 0.17. Everyone else is 0.83. And I'm going to go to the trouble and once again and do this the long way, like I said. We already know that this is 0.17, so I don't need to do anything here. But here we have a P is 0.17, X is 2, P equals 0.17, X is 3, P equals 0.17, X equals 4. So I'm going to do each one of those. Second vars geometric PDF, beginning with the first one, 0.17, X is 1, and we get 0.17. Well, we already knew that that was going to be 0.17, so this is the first one. Then we have the second one, second vars geometric PDF, 0.17, but our X value is now 2. This is 0.1411. And hang with me, I'm going to show you a shortcut to this in a moment. I really am. You just got to hang with me here. So second vars geometric PDF, 0.17, X is 3. And I get 0.117113. And that's because I have 1, 2, 3 guys that I met, or she met. Then second vars geometric PDF, 0.17, X is 4. And I get 0.09720379. 0.09720379. If I add up this plus this plus this plus this, just trust me on this, it equals 0.52541679. 8675309, and we got Jenny. So we added up all those numbers, okay? Well, that was a lot of work. But remember this, so that was a PDF. We added up all these PDFs. If you add up all the PDFs, what you're really doing is a geometric CDF. So we're going to do the same thing, but with a geometric CDF. And remember, we have a probability of success is 0.17, so that's what P is. But the X needs to be on the fourth value. So here's what we're going to do. Second vars, geometric. Here's my CDF. It's the last one at the very bottom. I'm going to press enter. P is 0.17. X is 4. Press enter one more time. And look, it added all these things up behind the screens. And so it added up all of those values, and it got me the work done very, very fast. And you're like, well, what work do I need to show for this? So here's what I need to see from you if you're for showing work. I need you to go, well, it's a geometric, it's a CDF, and then you're going to say P equals 0.17, X equals 4. That would be your work shown, and then you type in the calculator. And I'm going to do that really quickly again so you can watch one more time. So second vars, scroll down, and I get to geometric CDF. Press enter. 0.17 for my probability. My X value, I want to find the first honest guy among the first 4. And there's my answer, throwing pins at things. All right, so this right here is the introduction to the geometric probability. I'm about to do another video on where we actually practice some of these problems. So if I can stop this here.